All right, guys, so here's going to be an example problem video for our upper and lower boundaries as well as our percent error. So this is kind of what maybe a problem might look like on the IB exam or one of the exams that you take for me. So I'm going to follow all of the IB rules where we round to 3 significant figures for our final answer. And I'll kind of go through the way you want to write up your answers in your work for a problem of this type. So starting out, it's given in 2 parts here, okay? Frequently on an IB exam question, they will tell you, or always on an IB exam question, they will tell you off to the side in brackets how many marks that question is worth, so how many points it's worth. These 2 particular parts would probably be worth only a couple of marks in this case, okay? The way you want to go about answering this is you always want to indicate the part of the question off to the side that you're answering, all right? And you want to put typically all your work there so it's very clear for the grader the work goes to that particular part. And then you want to probably box in your answer at the end so they know what your final result is. This question says, find the upper and lower boundaries for the area of a rectangular flower bed given the length is measured to be 3.24. A lot of the times here, students want to find the area first, and then using that value, they want to find the upper and lower boundary. The issue with that is area is something that is calculated here in this problem. Not something that was measured. And we only ever apply the lower and upper boundaries to something that is measured, okay? So in this case, we would actually look, they tell us our length is measured to be 3.24 centimeters. I'm going to go ahead and erase this little 2 here because I don't really need it. It was just indicating what potential marks might be given here. So the length is measured to be 3.24 centimeters. So I'm going to go ahead and jot down the 3.24 centimeters. And I'm going to find the upper and lower boundary for that because that is the thing that is measured. That is the thing that potentially has a human error in the value. And what I do is I'm going to look for my lower boundary and my upper boundary, okay? If I go all the way out to 3.24, remember, I want values that round to 3.24. Be really careful. Frequently, I have students think, okay, I need to raise this by 5 and lower this by 5. And if I write that out, if I lower 3.24 in that manner, I would get 3.19. And you have to think to yourself, does this number round to 3.24? And it doesn't, okay? What I really need to do here is I need to extend this number out 1 more decimal place, okay? So I'm going to extend it out 3.2. If I'm going to be rounding up to 3.24, then that should have been a 3. And I'm going to extend it 1 decimal place as a 5, okay? 3.235, and numbers slightly above it will all round to 3.24. I then also need to do the same thing on the end here. Upper boundary, 3.24. I extend out 1 more decimal place as a 5, okay? And any number there, 3.245, anything lower than that will round down to 3.24, okay? And remember, a lot of the times I see students, they want to do this. 3.244. They want that cap to be something that rounds down to 3.24. The issue is if we make this our upper bound, we are excluding numbers like this. That would also technically round down to 3.24. Okay? So instead, I make my upper boundary 3.245. Even though this number doesn't round down to 3.24, that's fine because we don't have an equal to bar here. Okay? So there are my upper and lower boundaries for the length. I'm going to do the same thing right below it for the width. So I've got, or for the height. So I have 2.45 centimeters. Okay. So I'm going to go ahead and find my lower boundary here. So my lower boundary is going to be 2.445, okay, because that is the lowest possible number that'll round up to 2.45. So less than or equal to x, less than. And then my upper boundary, I'm going to extend out 2.455. Okay, again, that number doesn't actually round down to 2.45, but we acknowledge that by having no equal to bar underneath. Okay, and this will be our width. I believe in the problem it's written height. I'm going to go ahead and change that. We should probably have that be the width of the rectangle, not the height. Okay. If I draw my little rectangle here, area for upper and lower boundary, my area formula for a rectangle is length times width. So my lower boundary, okay, are going to be the two lower boundaries here multiplied together. Length times width. So I'm going to take 3 point for my lower boundary. 3.235 times 2.445. Okay? And that's going to give me 7.909575. And again, remember, we round to three significant figures in our answer. So 7.91 would be our three significant figures. And then I'm going to do the same thing for my upper boundary. Okay, so I'm going to go 3.245 times 2.455, and that's going to give me a value of 7.966475, which we round to three significant figures, so in this case 7.97. Okay? Final answer, though, we want to make sure we write it appropriately. So in the same manner that we've been writing all our upper and lower boundaries, we're going to write these the same way. So 7.91 is less than area less than or equal to area less than 7.97 as our final answer. Okay, so our area should fall, our true area, our exact area should fall somewhere in that range. All right. For part B, it says given the exact area of the flower bed. So part B, it said given the exact is 7.94. Determine the percent error between the exact value and the upper boundary that we found in part A. Okay, so our upper boundary was 7.97. But you want to be really careful here because when you go and use a value from a previous answer, you always want to use something that was unrounded. So when we go to do our percent error, I'm going to use my percent error formula here. Okay, so approximate value is going to go up top, but I'm going to use the unrounded answer that we had before. And there are ways in your calculators to save those values, but 7.966475 ... however far that value goes, minus our exact answer, 7.94. Okay. All divided by our exact answer, okay? Key thing is you always divide by the exact answer here. Close your absolute value bar, times 100. Type that into your calculator. And in this case, you should get 0.333%, remembering to round to three significant figures. Okay. Again, if you have any questions, please feel free to ask in class. I'm more than happy to help. You guys are welcome to come in anytime, whether that be during our SSRT homeroom period or any of my other classes. I have an open door policy. Otherwise, thanks for watching, guys.